Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host as usual is Tobias Macy, and today I'm interviewing Itamar Turner-Trauring about Eliot, a library for managing complex logs across multiple processes. So, Itamar, could you please introduce yourself?
Hi, my name is Itamar. I've been a Python programmer for quite a while, and I care surprisingly a lot about logging, as it turns out.
Yeah, it's one of those things that is far too often overlooked and, ends up being one of the more important pieces of your system, particularly when you need to debug it. Do you remember how you first got introduced to Python?
Yeah, this was 1999, I think, and I was doing web development in PHP, and I read some article about a web framework called Zope, Z-O-P-E, and it sounded really neat, and it had a lot of features that no other system at the time had, and so I learned Python by learning Zope. And for a while, Zope was a really big thing in the Python community, and has since been superseded, but I think a lot of people got to Python that way.
Yeah, it has sort of fragmented and dissolved into the broader Python ecosystem. There are a lot of elements of it that are still used in various other projects.
Yeah, I think Pyramid is probably the most Zope of the existing web frameworks.
Yeah. So, as we mentioned at the start, you are the author and maintainer of the Eliot library. So I'm wondering if you can describe a bit about what Eliot is and the problem that you were trying to solve when you created it.
So Eliot is a logging library originally designed for distributed systems, but now I think I've come to realize it's useful in pretty much any non-trivial application. And the issue I try to solve is that there's basically two audiences for your log messages. There's human beings who are going to be reading them, and there's automated systems that are going to be processing in them in a variety of ways. Maybe you can extract some metrics out of them. Maybe you're processing the data to show it to a human eventually. And for both these audiences, both computers and humans, logging is terrible. The standard way we log things is bad for computers and it's bad for humans. And so I wanted a logging system that would basically allow me to see the story, what actually happened and why. Most logging systems just give you a pile of facts. This thing happened, that thing happened, something else happened. Look, there's an error. And really what you want to know is not, here's a pile of isolated facts. You want to know why something happened, what caused it. You want logging to be a story about what happened. And so that was my goal in creating Eliot.
And you mentioned that one of the original intentions was for using it in distributed systems. So how does that particular problem domain differ from the standard logging environment that most people think about, where they're just concerned about the domain of their own particular process and not necessarily how that spans, machines or processors or network environments?
Well, so one part of it is that causality becomes that much more important because there's just a lot more moving parts. But also, if you're within a single process, you can often approximate causality by just looking at log messages in order of time. You can say, this happened after that, so probably this was caused by that. And often that'll be the case. Once you hit a multi-threaded program where you have different threads doing different things. Tracing this causality becomes much harder just by looking at timestamps. And once you have a distributed system across multiple machines, across different processes, you can't even trust the timestamps anymore because different machines can even have different clocks. And so especially when you're trying to debug like one particular error, like if two machines are off by a few milliseconds, which can happen, you can't tell what happened first. And so it can be really hard to figure out what caused what. And so once you hit that point where you're on multiple machines, being able to trace causality in some way that doesn't rely on time becomes much more important. I think that was probably where the original impetus of thinking about causality in a more structured way came from. As it turns out, tracing causality is great in like single processes too.
Particularly with the preponderance and growth of distributed systems in a lot of the technology companies, particularly as they continue to scale, the idea of distributed tracing and being able to trace transactions across multiple different microservices or service-oriented architectures has become something that's talked about fairly frequently. So how would you compare the capabilities and facilities that Eliot provides with something like the Open Tracing Framework or Zipkin?
Zipkin and similar systems are often much more focused on the communication between machines. You can use them internal to your process. I'm not sure people do. And they're coming from the perspective of people who are building really massive, massive applications. And so a lot of their focus is on performance. It's about timing. It's about like which message is going where. And so like Zipkin has a lot of stuff about like I believe it has like sampling where like it'll only show you like a percentage of messages and things like that. And Eliot is much more integrated into your processes. It's the idea is you actually trace the variables that you have inside your function so you can actually see what the data that was going through the system. And it also has a concept of a much more structured concept of causality rather than just a message span like this thing caused that. It also has a concept of or rather than just saying this message went from here to here, it has a concept of the core abstraction in Eliot is an action. An action starts and it has child actions, and then it succeeds or fails. And so what Eliot gives you is this structured tree starting from a root action saying, this action caused that action, which caused another action, and that action failed, and then went up a level to the next action. That one retried it, and that time it succeeded, and then this other thing happened, and eventually the whole operation succeeded. And so being able to actually look at that both within your single process and across multiple processes, if you have multiple processes, that tree of things that you tried and then either succeeded or failed, which is the logic of your process, right? You're writing functions and they return or they throw an exception. And Eliot integrates down to the level of that code, so it matches that structure. Like giving you that insight into the machine is a thing that things like Zipkin don't really do. One of the inspirations for Eliot is a system called Frost that was developed by Carl DeMarkin, who's the chief scientist of the company I used to work for. And he had this amazing demo where he had a distributed Scrabble solver, and he instrumented with his logging system, and the logging system traced actual parameters called the functions. And then, so he just, for all the important functions, it would just log, like I got called to these inputs, and it had like this causality loaded. I'm not sure it had a concept of success or failure. And then, so he'd run the Scrabble solver and aggregate the logs. And then he had a completely generic UI for looking at the logs. And then using the UI, he figured out that there's a performance problem that like 40% of the CPU is being spent on one particular function when it was trying to solve Scrabble with 2 blank squares, which basically wildcards. They can be any letter of the alphabet. And he did this like the profiling live. And so if you think about like a profiling system doesn't tell you what arguments were causing this performance problem. It just tells you this function is slow. And so profiler would never have told you this. And a tracing system would never really have told you this either, because like Zipkin, because it would tell you like messages going back and forth between the Scrabble solvers in the cluster, but it wouldn't get down to the level of the function. And so seeing that like the power and you can get from getting down into the level of function, looking at the actual data that is getting passed through was a big inspiration and why I made Eliot.
So is Eliot largely implemented on top of the standard library logging framework, or is it something that was written as a standalone application that is meant to supplant the built-in logging capabilities of Python?
It's basically meant to supplant it. The built-in Python logging is sort of standard. Here is a info message. It has a string, and you can sort of shove structured data in there, but it's not really what it's for, and it has no concept of context of like an action, and it would basically I could have built on top of it, but it would have just been a performance bottleneck and wouldn't have added anything. And so like Eliot is designed to replace Python standard logging. You can pipe messages from Python standard logging into Eliot, and those messages will be in the right place within the action tree. And so you can get content, like whatever logging is using the other logging systems, you can pipe into Eliot, and it'll know where you are in the tree of actions. But Eliot wants to own logging. It's not a layer on top.
So for somebody who has an existing application, it sounds like one way to begin introducing Eliot is to add it as sort of a wrapper and just consume the existing log messages and maybe implement it as like a handler for those messages so that you can embed those messages in the overall sort of process flow of what Eliot is recording.
Exactly, yes.
And how has the design and implementation of Eliot evolved since you first started working on it?
So my goals for Eliot were first have structured messages. This is at this point like a minimal criteria for a logging system. Having just human readable strings is not really acceptable. And I wanted to have causality, and I wanted it to have I wanted testability. Like I wanted basically if you have a system, it's crashed and it crashes like every 2 days. Having actual logs that tell you what you need to know is really important. And so if not for all applications, but for applications where getting these logs is really important, you want to be able to test that, write unit tests for your logging. And so from the start, I wanted it to be easy to write unit tests for your logs. And basically you can add logging assertions as annotations with decorators to your existing unit tests. So you don't have to like write a whole new set of unit tests for your logging. You just say, I have tested already tested my code. I'm going to add these extra assertions off on the side about the logs they produce. And so all of these things were in from the start. But I mean, this is a new concept. There's not that many systems like it, if any. And so I had to figure out what the APIs would look like and what the idioms would be. And a lot of that involved just using it in a real application and saying, oh, this is really repetitive. And so we need a nicer idiom. And so there was a lot of iteration on making the API simpler and more succinct. And I'm continuing to do that. There have been changes to Python over the years, so coroutines invalidate some of the assumptions that its implementation that you can just have a thread local context. So I'm going to possibly by the time this podcast is out, I'm going to have an initial release that knows about coroutines. And so a lot of it's just been, but yeah, mostly it's been learning how this new idiom works and what is the best way to structure it, because it was a new thing and there wasn't just an obvious model of how to implement it.
So one of the key concerns that you've mentioned a couple of times is the idea of having structured logging and having a somewhat standardized format for the application logs to be able to be consumed both by humans and machines. So I'm wondering if you can just elaborate a bit on why it's so important to have that standardized format for being able to make those logs usable outside of the application itself.
Okay, so this isn't necessarily saying that Eliot magically solves, because you're going to be dealing with, like, anytime you're dealing with real systems these days that are server side, you're no longer dealing with a single process. So like just a simple web server, you might have like a whiskey process like Unicorn, and then Nginx, and then a database, and maybe Celery, and then there's logs from your cloud provider if you're using the cloud, and your operating system logs. And so you basically have all these logs, and some problems are going to span multiple processes and multiple logging systems effectively, because you can't really assume everyone's going to log the same way once you're like the Linux kernel and your Python process are both things you might want to look at. And so you need to understand your system, you end up having to aggregate all these logs in some central place where like they can relate to each other. On a single machine, this has gotten better because the old days it was syslog, and syslog was in the end just you got a bunch of lines of text on your local file system. And these days, systemd has a logging container, journald, that can actually store structured information. You can query it, you can search it, you can use structured queries. It's pretty nice. So in the level of a single machine, it's gotten better. But once you're hitting server-side applications that are running more than one machine, you need to centralize everything. And if you're dealing with like, here's a line of text, then someone, probably the ops person who's running it, is going to have to write some regular expressions to extract the timestamp, and the logging level and some text, and then everything gets pushed into a centralized system like Elasticsearch. And so it's just, there's all this tedious setup and infrastructure work you have to do to get everything in one place. And so the more structured your data, the easier it is to just get it set up. And like, if it's going to take you an extra week to do it, then you might put it off, and then you don't have the centralization. So just every barrier in the way to getting that centralized aggregated set of logs, every barrier you can take away is great.
Yeah, that's definitely a pain point that I am all too familiar with, and one that I continue to battle with because I am responsible for a growing number of systems at my day job. So I have spent far too much time writing and debugging regular expressions to be able to parse some measure of meaning out of various different logging systems.
Right. And so if it starts out being in JSON, it's just much easier, because then you just say, oh, this field is a timestamp, this is the logging level, this is extra fields, and it goes into something like Elasticsearch that can take structured data, and then it's just there, as opposed to parsing lines of text.
And what are some of the most useful pieces of context that you see across some of the different projects that you've worked on, as far as being able to inject additional information into the log messages to be able to retrieve and interpret the sort of operation of the system, and potentially even use it for, as you said, being able to inject certain types of metrics?
So I guess I can give an example of, I was asking some Eliot users how they're using Eliot this morning. So there's a company in South Africa, and which is using Eliot for their systems, and they talk to a lot of external systems. And so every time they talk to the external system, it's another action using Eliot of, we sent this message, got a response, and every user interface interaction is the entry, it's like sort of the top of the tree of actions. So you say this user did this action, and then you can trace all the consequences. And so you have this tree, and each tree in Eliot is a task. It's like a top level action, and each one has a unique ID. And when an error occurs, they use a Sentry, which is a software as a service that lets you aggregate errors from your various systems. And so they store the unique ID of the task in Sentry. And then they have some tooling that then takes that unique ID and then looks up all the messages and builds up a tree. And so whenever an error occurs in some random system, they know within seconds, apparently, that this user did this action, which caused these things to happen, and they just see a tree of everything that happened and where the error was, from the point of user interacting with the system to all the queries to remote systems down to where the error was, which sounds like it makes debugging a lot easier, as opposed to an error happened, now I'm going to try to figure out where all the messages related to this were, and I don't know who caused it or why. So just being able to trace all the way from human interaction with a website down to all the resulting messages is really useful. I've seen in more complex systems, merely just tracing the network messages can be really useful. Another logging system that inspired Eliot was one that was built for airline reservation system I used to work on. And so you'd get airline reservation messages from other airlines or from travel agents come into the system, and that would talk to one system, which would send a message to another, and then send to another. And just being able to look through all those messages, you could see, oh, someone did a booking request, and then it did an inventory lookup, and then it did an availability call, and it failed there. And so you could figure out the situations that cause things. So being able to see all the messages of a trace, even if you can't see within the process, even that alone could be really useful. And another pattern I hadn't really expected, another use case, which I discovered in my latest job. If you're doing scientific computational pipelines, probably also just more generally big data. In scientific scientific publishing, like if you're doing research, you want your research to be reproducible. You want someone else, you want to be able to do the same thing yourself over again, get the same results, and also you want be able to say to someone else, you can run my code with these inputs and get the same answers. And so being able to so started using Eliot a little bit and being able to just say, here are all the steps in the computation, here are all the inputs, here are the outputs, and then being able, so you know exactly what the parameters were and what data went in and what data came out is really great for reproducibility. And it's kind of neat because I never expected that as a use case.
Yeah, being able to track the provenance of the data as it makes its way through the various systems is definitely an interesting use case and a problem that is, sort of perennial, as you said, in the sciences and also in data processing of any sort of scale, because anytime you mutate the data, you want to make sure that the source data was valid, and so being able to have an additional trail of actions that can be co-located with the actual processing is something that I can see as being immensely valuable.
I guess the South African company, they were also telling me they've hooked up Eliot to that because they already have Eliot logging. They've hooked it up to their unit tests and like possibly end-to-end tests as well. So when they have a test failure, they get a trace of everything that happened within that test. So instead of just a trace back, which is sort of a linear, here's who called me, with Eliot logging, you get like the whole tree of everywhere you put logs, which can be like almost as detailed as all the function calls if you go that if you want to be that detailed. And so when they get a test failure, instead of just getting a trace back, they get the whole tree of actions that led up to that point. So also useful in debugging tests.
Yeah, I can definitely see that being useful too for being able to encapsulate not just the specific steps that were taken, but the intent that was meant at each of those steps, so that you can more easily understand why the different actions happen throughout the system, rather than just, as you said, seeing a linear trace of where the where the process flow went.
Yeah, and linear trace, yeah, it doesn't, like if you have recursion or your program, like it starts getting really tricky to figure out what's going on.
And one thing that I was curious about while I was reading through the documentation is, because of the fact that you are creating these nested structures of actions, I was just wondering what the actual concrete log lines look like as they're being emitted from the system. Would you emit one log for each time you call to the Eliot system, and then they just have some sort of embedded metadata for being able to reference them to previous messages? Or is it actually a nested structure that eventually gets emitted as one step at the end of a particular process chain?
It is pluggable, but the standard way of logging is one line of a file with one JSON object per line. So fairly standard format. It's really easy to support with something like Logstash. So yeah, if you're doing that, then each JSON message has refers to the unique ID of the task it's part of, and then it has basically the path to its location in the tree. So it'll say like, I'm the second child of the third child of the root. And then you get a message for the start of an action, a message for any just standalone messages within the action, and then a message for the end of the action. And each of those is a JSON record. So you can load it into log storage systems like Elasticsearch that expect linear isolated messages, but within each message is sufficient information to extract the structure back out again. And so Jonathan Jacobs, Eliot users, has written a really nice tool that sort of just renders a ASCII tree of messages in your console, but you can also query it and extract information. Like you can visually it's human readable, so you can just visually sort it by the right column in your log viewing UI, and you'll be able to just read the structure, or you can write tools that parse it.
What have been some of the most sort of pernicious anti-patterns that you have seen in different projects where developers are setting up logging without necessarily having any specific intent behind those messages?
So the first one is logging levels. The way logging levels are defined in most systems is pretty terrible. Like there's info and warning and error, and sometimes there's critical, and it's never really clear what these levels mean. They mean different things to different people. So people will just pick one at random. And so the best solution to this I've heard is by someone named Daniel Lebrero. He works at IG.com, and they came up with a alternative set of logging levels. And I don't think everyone should use these particular ones, but I think the method they use is really great. And the logging levels they chose were in a test environment, in a production environment, tell me about it tomorrow, and wake me in the middle of the night. Those are their 4 logging levels. And those logging levels it's completely clear what each one of them means. It's not like info or warning. It's tell me about it tomorrow or wake me up right now, even if it's 3 a.m. And so whenever you're writing a log message, you think about the business consequences of this action. And then you say, is this a thing that someone should tell me about tomorrow? Or is this a thing that should wake me up in the middle of the night? And so it's harder to do this in libraries, to be fair. But if you're writing application logic, you should have some sense of what the implications of this log message are. And then you can come up with logging levels that fit your particular organization, and what, like, is this a catastrophe? Is this annoying? Is this just a thing that only needs to be in test environments for debugging there? And so coming up with logging levels that match to desired consequences seems like a really great idea. Yeah, another anti-pattern is just the standard plain text logging. If you're in the code tests, poke at it manually on your desktop stage, that works fine. As soon as you're writing something that is going to be running on a server in production, where the logs are going to be processed somehow, you really should be using structured data. And you don't have to use Eliot for this. Most logging systems, you can at worst coerce them to store structured data. Often these days they'll support it natively. As I mentioned, this isn't true for everyone, but in the cases where debugging something in production is going to be both very important and very hard, writing automated tests to ensure your logs are actually running and logging the stuff you think you need them to log is very important, because typically the point where your logging code is going to be run is on where you, especially if it's like the error path, is only going to happen rarely because it's the error path and this is a thing you don't expect to happen. And so it's very easy to get into this place where you have logging, but when every 2 weeks the crash happens, it turns out that logging code doesn't actually log what you thought it was. There was a bug in the logging code and you never caught it because it's such a rare case. And so there are systems where the cost of failure and the need to debug them is high enough that writing tests for your logging code is actually very useful. And the final anti-pattern I've seen is logging too much. And in my initial design for Eliot, I left out logging levels because I wasn't happy with the way logging levels were designed in most systems. And so you can just have a field which is logging level, like it's structured data. You can put whatever you want in it. But what it didn't occur to me is that the one good thing about forcing logging level on every message is that every time you write a message, you have to think about how frequently you have to put a tiny bit of thought of it. What is the consequences of this log message? Like, is it debug or not? And it's very easy to just throw lots of log messages and not think about the cost of running them in production on a critical code path. And the issue is that much of programming in general, you can't just focus on the product that you're creating. You have to think about the process that you use to develop software, and adding logging to a system is a process. So I had a coworker Madhuri, who described the process that she used to use at a previous company, and during development they would just add lots and lots of log messages, and then there was an explicit step before they shipped of going back and removing logs. Like part of their development process was, at this point in the development process, we're going to remove lots of logging because we know the system is more robust and we know there's going to be a performance cost. And so keeping in mind the sort of life cycle of logging, and like when you have to add it, when you have to remove it, and planning for that is an important part of adding logging to performance critical systems.
One of the approaches that I've seen in another library that I thought was interesting and fairly clever was in Logbook. They have the fingers crossed log handler where it will actually track the different sort of debug or info messages that happen in the system, but it won't actually emit them unless you hit an exception, so that when that case does happen, you have all of the additional contextual information that led up to that point. So how would you compare that capability with the facilities that Eliot provides in terms of its sort of tree of events, and how that plays in with the idea of log levels and filtering out the lower level logs?
Yeah, so that technique is often used in embedded devices. So like you have this isolated box somewhere that's running some software, and it doesn't have any way to talk to the external world. But sometimes your customer is going to call you and say it broke. And so what you do is you allocate a fixed buffer for logging, and it's a ring buffer basically. So when you hit the end of it, you just go back and overwrite the oldest messages. So you basically always have the last end messages of log messages. So when the machine dies, you can go over to it and get a dump of the last 1,000 things that happened, and that way you don't also just run out of storage with your log messages. And so when I encountered performance problems with too much logging in Eliot, that was one of the approaches I considered. And you could add it as much like Logbook has it as one of its handlers, you could add that as a handler to the equivalent concept in Eliot. And Eliot, while it doesn't have logging levels, it does know when it's logging an error or when it's logging a failed action. It does have those concepts because a failed action is a failed action. And so you could, if that was a useful thing for some, that could be like Eliot does have the information necessary. I've since been, the other reason I didn't add logging levels to Eliot originally was because I wasn't sure how it would semantically make sense in a tree. Because like in a traditional logging system, because each message is isolated, it's very easy to say just filter out all log messages with logging level debug. Whereas in a tree, it wasn't clear to me that that made sense, because what if the debug level action had a child that was an error? But I've since, one of the problems with having a new model, I've since realized that my initial understanding of that was wrong, and it actually semantically does make sense to do that. So at some point, I might, if I have the time, introduce logging levels into Eliot. But there's still I suspect I would probably just do it with only 2 levels, something like debug and not debug, or production, not production, and then more semantically rich things like wake me up in the middle of the night is a thing that users would add, because the decision about, is this a performance impacting log message is actually a thing that you want the programmer thinking about every time they write a log message. But the decision of, is this a meaningful error or not, is much more difficult and application specific and business organization specific. In one organizational context, it might be an error, some it might not. And I feel like logging levels beyond the distinction between this is a local error or not is very important, and the distinction within the logging system itself, and the distinction between this is expensive enough that you shouldn't do it in general is also useful, because reminder to the programmer at a minimum. The warning versus error versus critical, I feel like you can't really do that generically.
What have been some of the most challenging aspects of building and maintaining Eliot?
So as I mentioned, like it's a new model, and so figuring out what the right abstractions are, what a good usable API is, that took time. These days, it's a thing I maintain in my spare time, although since I'm using it at work, I might get an opportunity to do some work on it as part of my job, which would be nice. So finding enough time to work on it has been occasionally difficult. And there's also just the marketing aspect. Like Eliot has gotten users. There are people using it in real world production systems. The system it was originally written for, or most extensively used in, Flocker, is unfortunately a defunct project. But before the startup that created it died, like we had people using it in anger to like as a storage system for their container systems, and so there's quite a few systems using Eliot. But because it's a new system, it's taken me a while to get to a point where I can succinctly explain why it's so useful. So like you were reading a description of it as logging for distributed systems, and that's where it started. But I think that's not necessarily how we describe it today, and so I need to go back and sort of revisit the documentation, try to do a better job explaining it, so that more people can get the benefit of what it can give them.
And how would you compare it to some of the other third-party logging libraries that are available in the Python ecosystem, such as structlog, which you reference in the documentation, and logbook, which I referred to earlier, or any other sort of libraries that you can think of?
So logbook seems like I haven't used it extensively. I've just glanced at it. It seems like a system that put a lot of thought in how you route your logs and how you annotate them in different parts of your system, but it doesn't really have any, it doesn't give you any of the semantic richness that you get from Eliot or really from structlog if you use it. So in the end, the code that will generate the logs and route the logs and so on will be, well, you have a lot of power, but at the end of the day, the information you get is not going to be particular better than a logging system from 20 years ago. Like it's the same at its core, it's the same model. And I've only glanced at documentation, so I might be unfair. Structlog is a much more modern system in that, and in terms of the semantic richness you can get, because it from the start is designed for outputting structured data. And it has this nice model of you take a structured record and then you make a copy of it and you can override fields and add fields. So you can create a sort of initial message that has a trace ID, and then all the clones of it inherit that trace ID. And so you can get much more of a sense of causality than you would with if you just had text. And so structlog is sort of or systems like it are sort of fundamentally better than just logging human prose. I feel like Eliot gives you a better set of abstractions in terms of a tree of actions that can succeed or fail. Gives you more information about your code flow than just having a trace ID or something like that. You could emulate. You could build up what Eliot does on top of structlog, but then you may as well use Eliot. If you don't like Eliot, I would, if any listener doesn't think Eliot works for them, I would strongly encourage them to use structlog because it's much better than just logging strings. It's a nice library.
Are there any systems or situations that you can think of where you think that Eliot would be a poor choice for somebody who's trying to decide how to emit their logs within the system?
There's a bunch of places where it's overkill. A lot of web applications are just, this really simple query comes in, I do database query, I return a result. And that's all your application does in the end. And so if that's all you're doing, if it's just like, here's an input, I'm gonna do database return result, like it's overkill. It's not really going to give you much. Like you need your business logic to hit a certain level of complexity before there's any point in using it. And there are some technical limitations which I've started working on. Coroutine support did not exist at all until it'll be in the next release in 1.2 for async IO. But if you're using other coroutine based networking frameworks, Eliot could be extended to support other frameworks. And if you want that feature, I encourage you to file a ticket with saying I want coroutine support for tornado or whatever. Ideally, Eliot would just support all coroutine-based systems, but Python is missing the facilities, so doing it in a generic way would involve something unpleasant like on every log message traversing the stack and looking at frame objects or something awful like that, which would just destroy performance. So I don't want to do it. There's some talk about adding a coroutine friendly concept of context similar to thread locals to Python in some future version of Python, which would make this a lot easier. So those are two places. If you're in a really polyglot system, like if you're doing Python and JavaScript and Java and Ruby and so on, there's sort of a initial implementation of Eliot in JavaScript, but it's for the most, like other than that, it's a very Python-centric system. And so if you want to be using the same logging system across multiple languages, Eliot probably won't work for you. And that's off the top of my head. I'm sure there's other cases where it wouldn't quite be the right thing.
And you've mentioned some of the things that you have planned for the future work for Eliot. Are there any other improvements or additional features that you've been considering?
Yeah, so I have an experimental branch where I generate flame graphs from Eliot traces. Flame graphs are this really nice visualization by Brendan. I think Brendan Gregg came up with them. And so you can, I did this a little bit. My last job I was using Eliot. I never really finished the code. So you can get this basically visualization of a profile of the performance profile of a trace, and across distributed systems, this gets really useful. I didn't, maybe I didn't quite mention it, but part of the information that Eliot gives you is how much time was spent in every action. And I'm going to try and make it a little bit easier to get out, but it's all there right now. And so as a side effect of getting this tree of actions in your logs, you also have the timing of all these actions. Like you can say this action with these inputs took this that much time. And so there's a huge amount of performance information you can get out of the logs because you have the causality. Like you can say this started here and then ended here and caused these things. You can actually, it's also as your logging system is running, it's also as a side effect profiling your system. And so better tools to extract that information would be nice. And a thing I encountered at my job is computational pipelines, like scientific and big data, aren't actually trees. They're often graphs, directed acyclic graphs. So like you might take a chunk of data, split it up into parts, run all those in parallel, and then aggregate them again, and then do another computation, and then split off a couple more computations. And you can take a directed acyclic graph, a DAG, and break it up into trees. And that's one way to approach it, but it might be nice if there was some way to model these full graphs in Eliot. So trying to expand Eliot's conceptual model beyond trees, which could be a higher level abstraction. It could just be a convention for relating two trees together. That might be nice. And in general, just sort of as I learn more about scientific computation, seeing how Eliot can help with that is going to be interesting.
Are there any aspects of Eliot that we missed or any other topics that you think we should cover before we start to close out the show?
I keep talking about causality, and this is a key point about Eliot because stories are basically how we understand the world. Like pretty much every culture has these stories about, why does the world exist? Where did people come from? Why is the world the way it is? And it's sort of, the stories are how we try are sort of seem like they're sort of a key part in how human beings like manage to understand a sort of immensely complex world. And most of the stories that human beings come up with are wrong. Like there's fiction, which is very clearly made up, and it gives you the illusion of sort of explaining why something happened, but it's an illusion because someone just made it up. And we have the stories we tell about, this is what, if you're a historian, you try to understand this is what caused this thing to happen. Like there was, the gentry were on the rise during the 17th century, and so there was this, conflict between the gentry and the aristocracy, and then you end up with a civil war. And there's people who say the gentry was declining, and they have a different story. And these stories are, in the end, always partial and incomplete. but they do help us understand the world. But when you get to software, a universal Turing machine, which is in the end all a program is a really, really simple thing. It's a machine that takes these inputs and a program and does some things. Like the causality in a piece of software is completely predictable. It would take you a really long time to reproduce it by hand, but it is a system that is completely predictable, and you can trace the causality from beginning to end if you had the right tools. And yet, in this rare realm where causality is a thing we can actually say, we traced why this happened about a computer program, and you can't say that about pretty much anything else. You can only say that in approximation, maybe, if you're lucky and you have a few thousand years of scientific progress behind you. But for a computer program, you can trace this causality, and then we just throw it all away. Like we just write log message are like, a thing happened, another thing happened. And so this realm where we could have stories that are telling us exactly why something happened, we just say, not worth the bother. And there's performance reasons why we don't just have full traces of all the memory operations of a program. And so in the end, you have to simplify it somewhat. But this is a realm where we can actually have really good and accurate stories about why something happened. That was why I wrote Eliot. And if Eliot dies, no one ever uses it, but that idea persists and someone else comes up with a system that lets you do that, like that I think was worth it, because it's just we have the potential of being able to send our software and we just choose not to do so.
Are there any other topics that you think we should bring up before we close out the show?
I think that is all I have about logging, at least off the top of my head.
I definitely agree that being able to produce meaningful and relevant stories via the systems that we're running so that we can have a way at a human scale to be able to understand what is happening and at the same time have that consumable by additional machine processes to aggregate that information and produce higher level relevant information and actionable steps from that is a very valuable capability. And I've looked at Eliot a couple of times and considered implementing it in some of my projects, but the more I've spoken to you this evening, the more sort of pertinent of a decision that seems to be to me. So it's something that I'll certainly be revisiting as I continue to work in the Python space.
I'm glad to hear it, and I'm happy to answer questions, fix bugs, and so on.
And on that note, for anybody who wants to follow you or get in touch or tell you about how they're using Eliot or ask any questions, I'll have you add your preferred contact information to the show notes. And so with that, I'll bring us to the picks. And my pick this week is a podcast that I just started listening to called Moonshot, which focuses on a lot of the different startups and technologies that are producing some of the future-looking products and ideas, and I think it's definitely useful to keep things like that on your radar so you can have some measure of where things are progressing and what are some of the future directions that we might be working on as a species going forward. So they seem to do a fairly good job of addressing some of those different topics and speaking with people who are driving forward the state of the art in various areas. So definitely recommend taking a look at that one. And with that, I'll pass it to you. Do you have any picks for us this week?
Yeah, I would like to recommend the novel Middlemarch. The Eliot logging library is named after George Eliot, which was the pen name of Mary Ann Evans. It was she was one of the great novelists of 19th century. And Middlemarch is a really excellent novel she wrote. It's from the time when people were writing novels as serials, so that it get published week by week as she wrote it. And so it has this amazing structure, even as it was being published in a sequence. There's a couple of jokes in the Eliot documentation that will only make sense if you read the novel Middlemarch. So that is another reason I recommend reading it.
All right. Well, I appreciate you taking the time out of your day to join me and talk to me about the work that you've done on Eliot. As I mentioned, it's definitely something that I'll be taking a further look at and most likely implementing in some of my projects. So I appreciate the work that you've done on that and your time this evening, and I hope you enjoy the rest of your night.
Thank you. Thanks for having me. Really great being here.
Thanks for listening. Don't forget to go to podcastinit.com/linode to get your $20 credit to run your continuous delivery pipeline with GoCD, which you can download at podcastinit.com/GoCD. If you enjoyed the show, then don't forget to go to podcastinit.com/iTunes and leave a review.